Next, we have to discuss derivatives of composite functions. That is, the composite function means we have to express the function as the composition of two functions. That is, here, let us consider the function f of x equal to ax plus b whole cube. Let us take v of t equal to t cube. And here, t is equal to a function of x. That is, here v of t equal to t cube. Here t what ax plus b. That is a function of x. It can be also denoted by u of x. It is equal to ax plus b. That is, here we have to take the composition of two functions v of t and u of x. Next, we can consider v composition u of x. How can we consider v composition u of x? Can be written as v of u of x. That is, here v is t cube. Then u of x, here u of x is ax plus b. Therefore, v composition u of x, that is v of u of x, it can be expressed as ax plus b whole cube. That is, here u of x, it is t, the value will be ax plus b. Therefore, v composition u of x, it is ax plus b whole cube. Here v of t is t cube. Then the function v composition u of x is v of u of x. Here u of x is ax plus b. Therefore, v composition u of x equal to ax plus b whole cube. It is equal to f of x. That is, f of x can be expressed as the composition of two functions. Next, we can find out the derivative of the function f of x. That is, it is denoted by df by dx, because here the function is defined on x. Therefore, df by dx equal to what? We know that derivative of x raised to n is n x raised to n minus 1. The same manner here, derivative of ax plus b whole cube, it is equal to 3 into ax plus b whole square. Then into, next we can consider the d by dx of ax plus b. First, we can consider the derivative of the whole function. It is of the form x raised to n. That is n x raised to n minus 1. Next, we can consider the derivative of the linear function. That is, here we have to consider d by dx of ax plus b. That is equal to 3ax plus b whole square into d by dx of ax plus b. What? Here, d by dx of ax plus d by dx of b. B is constant. The value will be 0. d by dx of ax. That is a. Then next, we can consider it is of the form. That is 3ax plus b whole square into a. It can be expressed as the derivative of the function v of t and the derivative of the function u of x. How can we consider? First one, 3ax plus b whole square. That is, here t is equal to ax plus b. Then how can we consider? It is 3t square. We know that d by dt of t cube is equal to 3t square. Here t cube what? V of t. That is, dv by dt is equal to what? 3t square. That is, here 3 into ax plus b whole square. That is 3 into t is what? Ax plus b. That is 3 into ax plus b whole square will be equal to dv by dt. That is derivative of the function v with respect to t. Into, then next a. Here t equal to ax plus b. Then dt by dx. What is the dt by dx? Here dt by dx is equal to a. T equal to ax plus b. Then dt by dx equal to a. Therefore, here a can be written as dt by dx. That is, here the function f of x can be expressed as the composition of two functions v of t and u of x. Here f can be expressed as the composition of v and u. That is, v composition u of x equal to f of x. Therefore, df by dx can be expressed dv by dt into dt by dx. That is, here v can be expressed in terms of t. Therefore, first we have to find out the derivative of v with respect to t. Into second one, the function t can be expressed as a function of x. That is, t is of the form u of x. Therefore, we have to find out the derivative of t with respect to x. That is, f can be expressed as the composition of two functions. Therefore, df by dx can be expressed as dv by dt into dt by dx. Next, consider the question. Find dy by dx if y equal to sine of x cube plus 7. That is, here the function y can be expressed as the composition of two functions. First one, it is a trigonometric function, and second one, it is a polynomial function. That is, it can be expressed as the composition of two functions. Then how can we find out the derivative of y with respect to x? Here, first we can consider y can be expressed as the composition of two functions. That is, here f of x equal to y equal to what? Sine of x cube plus 7. Then next we can consider the function let v of t equal to what? Sine t. And here t is equal to, here t means the function of x. That is, it can be expressed as u of x. Here v of t and u of x are two functions. That is, f of x as the composition of v and u. Therefore, t equal to u of x is equal to x cube plus 7. Then next we can find out the derivative of f of x. That is, here f of x can be expressed as the composition of two functions. That is, sine of t. Here t is function of x. That is x cube plus 7. Therefore, it can be expressed as the v composition u of x. That is, here f of x equal to v composition u of x. Then df by dx, how can we consider? It is equal to dv by dt. We have to find out the derivative of v with respect to t into derivative of t with respect to x. That is equal to, here dv by dt, here v is sin t, then derivative of sin t is cos t, into then dt by dx, here t is equal to x cube plus 7, then dt by dx equal to what? 3x square. That is, it is equal to into 3x square. That is equal to, what is t? T is x cube plus 7, then substituting here, it is equal to cos of x cube plus 7 into 3x square. That is equal to 3 into cos of x cube plus 7 into x square. This is the derivative of the function y equal to sine of x cube plus 7. Next, consider the function y equal to sine of ax plus b. Find dy by dx. Here given y equal to sine of ax plus b. That is, f of x can be expressed as the composition of two functions. Let v of t equal to sine t. And here t is equal to what? U of x, it is equal to ax plus b. That is, it is a function of x, therefore it can be expressed as u of x. Therefore, y can be expressed as the composition of two functions v and u. Then that is, it is equal to composition of two functions. That is, f of x, it is equal to y equal to v composition u of x. Next, we can consider df by dx or dy by dx. That is, f dash of x or y dash, like that. That is, df by dx or dy by dx. What is dy by dx here? It is equal to dv by dt. That is, v is the function of t. That is, we have to find out the derivative of v with respect to t into, then next we can consider t as the function of x. Therefore, we have to find out the derivative of t with respect to x. That is, dy by dx can be written as dv by dt into dt by dx. It is equal to, here v what? Here v is sin t. Then derivative of sin t is cos t into dt by dx. Here dt what? Ax plus b. Then dt by dx. It is equal to a. That is equal to, here t what? Ax plus b. Then substituting, that is cos of ax plus b into a. Next question, find the derivative dy by dx if y equal to cos of root x. Here given y equal to cos of root x. Then y can be expressed as the composition of two functions. That is, here v of t equal to cos t, and here t is equal to what? Here t is equal to u of x equal to root x. Then next we can consider dy by dx. Dy by dx can be written as dv by dt into dt by dx. Then substituting here v of t is cos t. Therefore, derivative of cos t is minus sin t into dt by dx. Here t what? Root x. Therefore, derivative of root x, that is d by dx of root x is 1 by 2 root x. That is equal to, then here minus of 1 by 2 root x into then sin t. Here t what? T is equal to root x. Therefore, we can replace t as sin t. That is sin of root x. It is equal to minus 1 by 2 root x into sin root x. Therefore, dy by dx equal to what? Minus 1 by 2 root x into sin root x. Next, find dy by dx if y equal to cos of sin x. Here, let v of t equal to cos t. And t equal to what? It is expressed as the function of x. Therefore, u of x equal to sin x. Next, we can consider dy by dx. It is equal to, here y can be expressed as the composition of two functions v of t and u of x. Therefore, dy by dx equal to dv by dt into dt by dx. It is equal to, here v what? Cos t. Then dv by dt, that is d by dt of cos t. It is equal to minus sin t into dt by dx. Here t is sin x. Then d by dx of sin x is cos x. That is equal to minus of sin. Here t what? T is sin x. Therefore, minus of sin x into cos x. Therefore, dy by dx equal to minus sin of sin x into cos x. Next, we have to discuss derivative of implicit functions. How can we define derivative of implicit functions? First, we have to define what is an implicit function. First of all, we have to consider the function x plus y equal to 5. Now here, we can write y equal to 5 minus x. That is, here y can be expressed as an explicit function of x. That means here y is expressed as an explicit function of x. That means here the function y is equal to f of x. It can be expressed, that is y equal to f of x form. It is called an explicit function. Let us consider some function x plus y equal to sin y. Now here this function cannot be expressed as the form y equal to f of x. It cannot be expressed as the form y equal to f of x. Therefore, this type of function, it is called an implicit function. That is, it cannot be expressed as the form y equal to f of x. That is, this type of function is called the implicit function. First one, explicit function means y can be expressed in terms of x. That is y equal to f of x form. Next, we have to consider the function x plus y equal to sine y. It cannot be expressed as the form of y equal to f of x. That is why this function is called the implicit function. Next, how can find the derivative of this implicit function? That is, the function is of the form x plus y equal to sine y, like that. Next, how can we find out derivative of an implicit function? Let us consider the function x cube plus y cube equal to sine of x plus y. Find dy by dx. Here, first step, here we have to differentiate on both sides with respect to x. First step, differentiate on both sides with respect to x. Second case, take all terms involving dy by dx on one side and the remaining terms on the other side. That is, take all terms involving dy by dx on one side and the remaining terms on the other side. Then last step, solve dy by dx. First, we have to differentiate on both sides with respect to x. Then second step, take all terms involving dy by dx on one side, grouping. We have to take dy by dx terms on one side and the remaining terms on the other side. Then after that, we have to solve dy by dx. This is the step. Now here, the given function is what? X cube plus y cube equal to sine of x plus y. Here, first we have to differentiate on both sides with respect to x. Then d by dx of x cube plus d by dx of y cube equal to d by dx of sine of x plus y. Now here, the first term, d by dx of x cube, that is equal to 3x square, plus next d by dx of y cube, that is 3y square into dy by dx again. With respect to x, therefore we have to find out the derivative of y with respect to x also, that is 3y square into dy by dx equal to, now here d by dx of sine of x plus y. First we have to consider it is of the form composition of two functions, sine of, therefore sine of x plus y, d by dx of sine of x plus y means cos of x plus y. Next we can consider d by dx of x plus y, that is derivative of first plus derivative of second, that is here d by dx of x plus d by dx of y, that is equal to 3x square plus 3y square dy by dx equal to cos of x plus y into d by dx of x, that is 1. That is cos of x plus y into 1 plus dy by dx. Inside the bracket, it is 1 plus dy by dx. Next, we have to take all terms involving dy by dx on one side. Now here, 3y square into dy by dx on left side and cos of x plus y into dy by dx on right side. That is equal to 3x square plus 3y square into dy by dx equal to cos of x plus y into 1, that is cos of x plus y plus then cos of x plus y into dy by dx, cos of x plus y into dy by dx. Next, we have to group all terms involving dy by dx on one side and the remaining terms on the other side. Now here, that implies 3y square dy by dx. Then now here cos of x plus y into dy by dx. Then take this side, that is minus of cos of x plus y into dy by dx equal to, on the right side here cos of x plus y. Then now here 3x square on the left side, we have to take it as right side, that implies minus 3x square. That implies now here 3y square minus cos of x plus y into dy by dx, that is dy by dx is common terms, then we have to take it as a group, that is 3y square minus cos of x plus y into dy by dx equal to cos of x plus y minus 3x square. That implies here dy by dx what? Dy by dx equal to cos of x plus y minus 3x square divided by 3y square minus cos of x plus y. Now here 3y square minus cos of x plus y not equal to 0. 3y square minus cos of x plus y not equal to 0. If it is 0, the derivative does not exist. That's why we have to specify the denominator not equal to 0. That is 3y square minus cos of x plus y not equal to 0. Consider the question. Find dy by dx if ax plus by square equal to cos y. Solution. Given ax plus by square equal to cos y. First, we have to differentiate on both sides with respect to x. That is d by dx of ax plus d by dx of by square equal to d by dx of cos y. Now here d by dx of ax, that is a, plus d by dx of by square, that is 2by into dy by dx, that is by square, that is derivative is 2by into dy by dx equal to d by dx of cos y, that is minus sin y, then again dy by dx. Now here we have to group in dy by dx terms on one side, that is 2by, then minus sin y, take it as this side, that is plus sin y into dy by dx, that is grouping. Directly we have to group dy by dx terms equal to minus a. Then dy by dx equal to what? Minus a divided by 2by plus sin y. Next question, find dy by dx if sin x plus cos y equal to xy. Now here, the given function is what? Sin x plus cos y equal to xy. First, we have to differentiate on both sides with respect to x. That is d by dx of sin x plus d by dx of cos y equal to d by dx of xy. Now here, d by dx of sin x is cos x. Then d by dx of cos y, that is minus sin y into dy by dx. That is d by dx of cos y. We have to consider first the derivative of cos y, that is minus sin y, then again dy by dx. With respect to x, we have to differentiate y, that is dy by dx equal to, now here d by dx of xy, we have to apply product rule, that is first x into dy by dx plus y into d by dx of x, that is 1. It is of the form x into dy by dx plus y. Then next we have to arranging dy by dx term. Now here we can take minus sin y dy by dx on this side. That is, it can be expressed as x plus sin y into dy by dx equal to, then next we can consider y on left side, that is cos x minus y. That implies next we can consider dy by dx. Here we have to find out dy by dx. Therefore, dy by dx equal to what? Cos x minus y divided by x plus sin y. Next, find dy by dx if x square plus xy plus y square equal to 100. Now here, first differentiate on both sides with respect to x. That is x square plus xy plus y square equal to 100. Then d by dx of x square plus d by dx of xy plus d by dx of y square equal to d by dx of 100. Now here we know that derivative of constant is 0. That is the right side is 0. Next we can consider the left side, d by dx of x square, that is equal to 2x plus d by dx of xy. Here we have to apply product rule, that is x into dy by dx plus y into d by dx of x, that is 1. Then plus, then next term d by dx of y square, that is 2y into dy by dx equal to 0. That is the derivative of constant equal to 0. Next we have to consider dy by dx term. Now here x into dy by dx plus 2y into dy by dx. That implies x plus 2y. That is x plus 2y into dy by dx equal to, now here 2x plus y. Then take it as right side, that is minus 2x minus y. That is, it can be expressed as minus of 2x plus y. Both are minus, therefore we can write minus of 2x plus y. That implies dy by dx equal to minus of 2x plus y divided by x plus 2y. Next question, find dy by dx if xy plus y square equal to y plus tan x. That is, here first we have to differentiate on both sides with respect to x. xy plus y square equal to y plus tan x. Then d by dx of xy, here you have to apply the product rule, plus d by dx of y square equal to d by dx of y plus d by dx of tan x. Now here d by dx of xy, that is x into dy by dx plus y into 1, that is d by dx of x, then d by dx of x is 1, plus d by dx of y square, that is 2y into dy by dx equal to d by dx of y, that is dy by dx plus d by dx of tan x, that is sec square x. Derivative of tan x is sec square x. First we have to take all terms involving dy by dx, that is here x into dy by dx, then plus 2y into dy by dx, then this side it is also dy by dx, then we can take on the left side, that is minus dy by dx equal to, on the left side the remaining term is y, then take it as other side, that is minus y plus sec square x. Next we can consider x plus 2y minus 1 into dy by dx. We can take the coefficient of dy by dx, that is x plus 2y minus 1 into dy by dx equal to sec square x minus y, that is minus y plus sec square x. It can be written as sec square x minus y. Therefore, dy by dx equal to what? Sec square x minus y divided by x plus 2y minus 1. Therefore, dy by dx equal to sec square x minus y divided by x plus 2y minus 1. Next question. If xy equal to tan of xy, prove that dy by dx equal to minus y by x. That is, xy equal to tan of xy. Then first we have to differentiate on both sides with respect to x. That is, d by dx of xy equal to d by dx of tan of xy. That implies d by dx of xy, that is x into dy by dx plus y into d by dx of x, that is d by dx of x is 1, equal to d by dx of tan of xy. D by dx of tan x is sec square x. Therefore, d by dx of tan of xy, that is sec square xy into d by dx of xy, that is x into dy by dx plus y into d by dx of x, that is 1. That implies x into dy by dx plus y equal to sec square xy into x into dy by dx. That is x into sec square xy dy by dx plus y into sec square xy. Then next we have to group dy by dx term. That is, here x into dy by dx, on this side x into sec square xy dy by dx. That is x minus x into sec square xy, that is all terms including dy by dx, equal to y sec square xy on this side. Then the left side, the remaining term is plus y. Then take it as right side, it is minus y. Next we can consider x minus x into sec square xy dy by dx. Here we can take minus x outside, that is minus of, now here sec square xy minus 1, that is minus x taken as outside. Therefore, this term will be sec square xy minus 1, that is minus x sec square xy plus x, that is it can be arranging minus x taken as outside. Therefore, minus x into sec square xy minus 1 dy by dx equal to, now here we can take y outside, y into sec square xy minus 1. We know that 1 plus tan square theta is equal to sec square theta. Therefore, tan square theta is equal to sec square theta minus 1. That implies minus x into sec square y minus 1. That is sec square theta minus 1 is tan square theta. Therefore, this can be changed into sec square xy minus 1 can be changed into tan square xy. That is minus x into tan square xy dy by dx equal to, now here y into sec square xy minus 1. That is, this is of the form sec square theta minus 1. Sec square theta minus 1 is tan square theta. Now here sec square xy minus 1 is tan square xy. Here tan square xy on both sides cancelled, tan square xy. That implies minus x into dy by dx equal to y. That implies dy by dx equal to minus y divided by x. That is minus x into dy by dx equal to y. Then dy by dx is minus y by x.